Hello, everyone. I'm super excited to be here today. This is my first Wix engineering talk, so I really wanted to bring something interesting and practical for you today. When I started planning this talk, I thought to myself, React 19 is the next big thing, so I decided I want to talk about it. But I also want to share some of the work I've been part of over the past year, which is upgrading our Wix sites to React 18, yes, and applying its new features. So these updates have significantly improved Wix sites' performance, and I'm excited to share with you also the possibilities that we can have with React 19. By the end of this talk, I hope you'll have a better understanding of React's new features and maybe apply them to your existing or new web applications. So this is me. For those of you who don't know Jenny, so she's with me in this picture. My name is Hadar, and over the past year, I've been working on live sites performance as part of the viewer team. And you can tell that we very much enjoy coming to work together, me and Jenny. So this is what we are going to talk about today. First, we'll understand what concurrent rendering in React means. Then we'll cover React 18 features we already applied and see their impact. And finally, we'll explore React 19 features and see some code demos. So, like I said before, lately I worked on upgrading our sites and apps to React 18. This transformation enabled some really significant features that led to amazing improvements in our overall performance and specifically our site's interactivity. So before we begin exploring the new features, I want to understand with you what exactly can impact site interactivity. As we know, the browser has a single thread, so it can perform one action at a time. In order for it to respond quickly, when the user interaction is made, it needs to be freed often. So the more we free the main thread, the better interactivity we get. So we understand that the main thread is a valuable resource, and we want to use it effectively. That means that the more we avoid unnecessary main thread work or delay work that can be delayed, the better interactivity we will get. So with the following two conclusions in mind, it will be easier to understand why the new features we applied improved our site interactivity. So those are the features we are going to talk in a bit. But first, I want to talk about concurrent rendering in React, which is not really a feature, but more of an implementation detail. It's a new mechanism that enabled React to implement the new features it provides. Up until React 18, the rendering process was one big task, which can have bad influence on performance since it blocks the main thread. With concurrent rendering, the rendering process is split into multiple tasks. This allows our application to handle other tasks in between components rendering. One way we can intentionally pause and resume rendering is to differentiate between updates. So we can mark certain updates as transitions or non-urgent updates. And this way we can prioritize certain rendering tasks. So that brings us to the first feature we applied, which is initial concurrent rendering. So we will first understand what exactly that means, and then we will see the before and after results of applying it. So we marked our initial app rendering as a transition. And most of our sites at Wix contain big amount of components, so the first rendering process can become very long. When it is marked as a transition, React knows to pause the rendering when a user makes an interaction, and then resume it. And even more than that, React knows to prioritize the rendering of the component the interaction was made upon. So we did something similar to the code you see here. We wrapped the call to hydrate root with the new start transition API. And now let's see how it looks like. So here we can see the results of profiling one of Wix's sites. We see the tasks and the time each one took. And this specific part is the first rendering process. So you can see that before we had one big task. And after, it contains multiple small tasks, which allows us, as we said, to handle other tasks in between the rendering. And what you see here, we achieved with a single line of code that we saw in the previous slide. That leads us to the next feature, which is selective download and iteration using Suspense, and the new API render to pipeable stream. So I guess most of you already heard about Suspense and iteration, but let's break it down a little bit. So first of all, iteration. It's the process of rendering the component in the client after SSR to make it interactive. So the components are visible since we get the HTML from the rendering in the server, but then we need to make them interactive. And when we talk about Suspense, first of all, it's a React API that can be used to suspend the component execution. It is a way to show a fallback while the component is suspended. And also in previous versions of React, we had the Suspense API, but it didn't work in SSR. And starting React 18, we can use Suspense also in SSR. That means that we can stream parts of the HTML once the components are ready, without the need to wait for the entire tree to be rendered. This is possible because of the new API called render to pipeable stream that we are now using in the server to render our React tree. And this is instead of render to string that we used up until now that does not support streaming or waiting for data. Then in the client, we can selectively hydrate the components. And in order for Suspense to work, we need to either throw a promise from the inner component or wrap the inner component with React Lazy. As long as the inner promise is pending, the Suspense will show the given fallback. So if the last sentence was a bit confusing, don't worry, because we'll see a code example when we get to the React 19 part. So let's see how it is all connected. Selective download and hydration using Suspense. Our goal is to improve site interactivity. The user can't interact with components he cannot see. So by avoiding download and hydration of components that are outside the viewport, we can reduce the main thread work and give the user a better experience. In Wix, we decided to achieve that by triggering download and hydration of large components, such as widgets and containers, only when they enter the viewport. And now let's see this feature in action on Wix.com site. See here is that I'm scrolling down Wix.com site, and then we see the scripts in the network tab that are downloaded dynamically as components and widgets enter the viewport. And that way, we reduced both network requests and main thread work, since we parse and execute much less scripts. And we couldn't implement what you see here before React 18, because as I said, SSR didn't work, Suspense didn't work in SSR, meaning we would have to give up SSR because React Tree has to be compatible between the server and the client. So the features we covered made a huge impact on Wix interactivity score. So now I want to show you some of the results. Here you can see Wix interactivity results over time, measured by Google and compared to other similar companies. The y-axis is the percentage of sites with good interactivity score. So you can see that before we were not in a very good place. And after applying React 18 optimization features, we measured a 36% improvement, which is really amazing. So this puts Wix ahead again, as it should be. And this is super important because it's our and our users' hallmark card. So with these amazing results in mind, we can understand the great potential React features can offer. So now I want to share with you some of the new features React 19 brings to the table. So React 19 brings many great features. I chose to talk about this main one with you. And we'll also see some code demos. So we'll start with the use hook. This API lets you read the value of a resource, like a context or promise. It enables writing async code in React components. It can simplify our code and make it shorter. And another cool thing is that this is the only hook that can be used inside condition and not only in the uppermost block of the component. Now we'll see some code. So first, a simple example of a to-dos list without the use hook. So this is the to-dos list component. We have two states, one for the to-dos item and one for loading state. When the component is mounted, we turn on the loading state. Then we fetch the to-dos item and store it in the to-do state, and finally turn off the loading state. Here we can see the HTML structure. So we generate different HTML for the loading state, and otherwise we'll generate a to-do component for each item in the list. Now we'll see how use simplifies our example. So this is the new to-dos component. Here I called fetch to-dos directly in the use hook. But this won't work. This will cause the fetch to be called every time we render the to-dos component, which is not something we want. Instead, we will create a promise in the to-dos component parent and pass it as a prop. This promise will be resolved when the fetch is completed. The use hook will postpone the rendering of the component until the promise is either resolved or rejected. But we still need to handle the loading state. So let's see where it is done now. So this is the main app component. We fetch inside an independent use memo, which is good because it will be only called once. And the promise is passed to the to-dos component. Finally, we wrap the to-dos component with suspense. That means that as long as the to-do promise is pending, the fallback with loading state will be displayed. So we can see here the final result. With use and suspense, we get a much more elegant and cleaner code. The next feature we'll discuss is server components. So server components were already introduced in React 18, but were considered experimental. And in React 18, it should be a stable feature. Server components are static and are not interactive. We generate the static HTML on the server, and they are not being hydrated in the client. And more than that, they are also not downloaded to the client. They can be either generated once at build time or for each request in our web server. And something we do need to notice is that we can't use server components inside client components, only the other way around. And we'll see a solution for that in a code example later. So we can get many benefits by using server components. Server components run exclusively on the server, so we don't need to download their code to the client. Since we don't download them, we also save time for not having to parse and hydrate them. And they can give us an extra level of security. For example, if we want to use an API that we don't want to be exposed at client. So now I'll demonstrate how we can use server components in our to-dos example. This is the app component now. Maybe you noticed that up until now, there was a use client annotation at the top of each component file. So in this demo, I used Next.js. So when we remove the use client annotation, Next automatically marks the component as a server component. We now fetch the to-dos list only in the server, and then the to-dos item are passed as a prop to the to-dos component. We still handle the loading state by wrapping the to-dos component with a suspense. And pay attention that the app component is an async function. We can do that because it is a server component. This is our new to-dos component. The difference from the previous example is that this is also now a server component, and that it receives the resolved to-dos list instead of the promise it used to get. This is the single to-do component, and this is the only client component in this example. And it must be downloaded and rendered in the client since it is interactive. We use a dynamic state. Each time it changes when the user toggles the completed checkbox. So we must run this component's code in the client. We'll now see another example for the to-dos app, but now with a server component that is used within a client component. Now, this is the new to-dos component. I created a new server component called title. It's a static component that renders the title of a specific to-do item. Since it is static, there is no need to hydrate it in the client and download it. The only problem is that we can't use it directly in the to-do component since it is a client component. So here we see the solution. The title component is created in the parent server component and passed to the to-do component as a child. Passing it as a child is the common way to do that, but we could also pass it as a different kind of prop. And this is the to-do component. We place the children prop within the component structure. And this is a screenshot of the running demo. On the right, we can see React DevTools and the components tree, and we can see the server annotation on each server component. And you can notice the children prop that is passed to the to-do component, which is pure HTML string. So we've seen that use simplifies our code, and that server components can give us many performance benefits. Now I want to show you the power of their combination. As I demonstrated before, in Wix we selectively hydrate widgets and containers when they enter the viewport. And in order to achieve that, we had to write a complex API that handles the internal promise. The use hook in React 19 basically encapsulates this complex API, so it dramatically simplifies our code. Imagine that our to-dos list had hundreds of items. We can optimize our application by hydrating each to-do item as it enters the viewport instead of hydrating the entire to-dos component on page load. So this is the code example we are about to see. And the structure looks like that. So for each to-do item, we'll have a new component called to-do wrapper that wraps the inner to-do component with a suspense. And the implementation is a bit complicated, so try to stay focused. This is the to-dos server component. Here we wait for the data to be fetched in the server. Then we pass each to-do item data to a to-do wrapper component. Now we'll break down the implementation of the to-do wrapper. So in SSR, we want to immediately render the to-do item so that it will be streamed to the client and the user will see the HTML. This is why we pass a resolved promise with the data to the to-do component. In the client, we create a ref and attach it to the to-do wrapping div. This ref will be later used as an indication for the intersection observer. Here we create the to-do promise that is passed to the to-do component, and we wrap the to-do component with a suspense and pass this promise as a prop to the to-do. And finally, after the component is mounted, we create the intersection observer. So this is the part that observes when the specific to-do item enters the viewport. So we pass the current ref to create intersection observer function. This function returns a promise that will be resolved when the specific to-do element enters the viewport. We won't go into the implementation of create intersection observer, but basically it uses a JavaScript API that observes when a specific HTML element is intersecting with the viewport. This is our single to-do component. As we saw, it receives a to-do promise as a prop. The to-do promise is transferred to the use hook. That way, it will be suspended until the to-do is in our viewport. Here I added a log, so we can see when the first render of each to-do component occurs. So I hope we can see the video now. We will see that when I scroll down the to-dos list, we will see the console log that I added each time a to-do element enters the viewport. So this can have a huge performance impact on sites that include components with heavy code, such as data fetching and state mutations. Last but not least, we will discuss the React compiler. The React compiler is still experimental. It is a build-time tool that automatically converts our components code into an optimized version. As long as you follow the rules of React, there is no need to rewrite code for the compiler to work. The compiler optimizes components by automatically memoizing their code, and it focuses on skipping unnecessary re-renders. We can say that overall it improves our dev velocity. So we know that React already provides APIs such as use callback, use memo, and React memo for memoization. But of course, in big applications, such as Wix, we can sometimes miss spot where we could memoize. So in those cases, the compiler is very helpful and save our time. We won't go into the implementation details of the compiler, since it can be a whole separated talk, but we will see a code demo of how it works. This is our simple counter application. It holds a count state. The count state is passed to the counter component and changes whenever the counter is clicked. It includes another child component that receives no props. And as you can see, the child component is static, so potentially we would think it should be rendered only once. Each time that I click the counter, we see the console log that is within the child component, that it is being re-rendered. And this happened because the count state is at the level of the app component. And so each time the count changes, it causes re-render of the entire tree under app. Of course, we could solve that by wrapping the counter component with React memo, but we don't have to do that when we're using the React compiler. When I click the counter, there are no console logs. And we could also see in React DevTools in the component tree that there is an indication on each component that was memoized by the compiler. But you will have to believe me. So we sure did cover a lot in 20 minutes. And there are many more new features I could talk about, but we would need a lot more time to cover them all. So I hope that, like me, you are now excited about the new possibilities we can bring to our product at Wix with the new features React 19 brings. And if you are interested in making a huge impact on millions of Wix sites' performance, the viewer is hiring, so talk to us. Thank you.